I'm going to go through a bit faster just because we've done the rest, and I want to show you how to check an oblique asymptote. So the point of this one is the check. So first of all, there's no hole, right? So hole, none. Vertical asymptote, gave you x equals 6. Horizontal asymptote, this is degree 2, this is degree 1. So then none, right? So none, and then it does have an oblique. Okay, so I'm just going through a bit faster for the other stuff because we've done that now. For the oblique, you're going to take the oblique and you're going to go over here and you're going to go, okay, synthetic or polynomial, it's up to you. So for the oblique, I'm going to go 6 here, 1, 0, 2. And I'm doing this fast because you should know how to do synthetic. Grab the 1. 6 times 1 is 6. Add it up. 6, 36, 38. That's my remainder. What is my equation then? Of my asymptote? X plus 6. So that goes over here. So y equals x plus 6. That part's okay? All right. Let's go ahead and get the x-intercept, y-intercept, and then I'll show you the check. So the main thing on this question was the check. So let's do x-intercept, y-intercept. So x-intercept is going to be 0 equals x squared plus 2. I know that this part goes away, right, because it goes up. And this one we know x squared plus 2, no solution. Right, no solution on that one. And then the y-intercept is when f at 0. So this will be 0 plus 2. You can go through this faster. So this will be negative 1/3. All right, so I've got that. We can do the positive, negative, all that jazz in a second. I'll do it from the graph. What else do I need? Positive, negative, and then the asymptotes. Okay, so let's do the asymptote. So I'll do the positive, negative in a second. Let me graph it. I'm going to do a rough sketch here, and then I'll do the approach check in over here. So when you graph this, I'm going to do my vertical asymptote is at 6. Remember, it's not to scale. Definitely not to scale. This is x equals 6. My oblique asymptote is a line. The line is y equals x plus 6. Y equals x plus 6 means that the y-intercept should be 6. Does that make sense? 6. And other than that, positive. You don't have to give me exactly step by step. So just 6 and then a dashed line. Other than that, I don't know. Okay, close enough. Make sure they crisscross so that you can kind of get some shape out of it. That's all. So I want 6, and other than that, whatever. Yep, we're going to do y equals x plus 6. We always label the asymptotes. Yes, good. Thank you. Okay, label. We got that. Okay, and all I needed was the 6, right? Don't give me, I don't need step by step. Just, it's positive slope. All right. Now, x-intercept, do we have any? No. Y-intercept? Yes, I'm going to do that in pencil in case I need to erase something, but it's somewhere down here. It doesn't have to be the scale, so you don't have to shove it right up here. Just make it slightly lower. It's easier to graph. Okay, so I know that this is going to be at negative 1/3. I'll fix the dot later on. It will not. What most people do is you do this. You go, oh, cool. So I'm going to do this, drag it up, make sure there's no bump here, and then eventually it will just plateau to be this one here, like that. What mistake did I make? How can it not be like that? Yeah. There's double there, right? Like, whoa, you doubled mistake. Some people tried to do a vertex here. I never said there's another x-intercept. You cannot. You've just created something wrong. Okay? And now you're twice wrong. Graph is wrong, and you've got x-intercepts here. So no. So it can't go through. So we know it must do this, right? It goes through, and it must turn around. So there you go. So that's what's going to look like. So make sure you do a double check of what you drew, and then go, I get it. So I know that's right. How about here? Can I possibly draw the graph like this? Sloping up and tangent? No, because nope, no x-intercept. Again, you kind of go, oh my gosh, these x-intercepts are really important. See how important that is? If you accidentally do a positive negative root 2, you've now messed up your whole graph. You've got it facing the wrong way, your approaches are going to be wrong, you've just now snowballed your mistakes. Don't make little calculation errors because it will snowball. So I know it has to be here. Okay, so that's definitely my graph. So 100% I know my graph is there. Let's go ahead and do my check. Is that good? So I know my graph is there. Now I'm just going to double check it. Sometimes you don't know where your graph is, and the check is going to tell me where the graph is. So this one I can still figure it out, right? So here we go. So now let's do our check to make sure we've got the right information. So for my check, we're going to do my vertical asymptote. Okay, vertical asymptote. What do I check? I'm going to check x equal 5.9, and I'll give you my values just so we can go faster. I got exactly negative 368.1. My second check, I checked 6.1, and I got 392.1. That's telling me on the left, it was heading down, perfect. And on the right, it was heading up, perfect. So that matches what we drew, right? So it's kind of like, that's good, that's good. What I thought was happening was happening. If I ask you to write the approach, right? So if I say approach, then all you're writing is the answer, and my answer would be the limit as x approaches 6 from the left of the function is heading down. So each one of these has an infinity or negative infinity, potentially, but where we use it is different. You'll get used to it. 6 from the right, it was heading up. Okay. I have to do the oblique asymptote. Okay, and I'm going to show you my check. Okay, I want to finish this example, so I'm going to go ahead and finish it. If you need to leave, you can leave, but I'm going to go ahead and finish it. So my check for this is just like the horizontal. Can you close the door, just so it's clear? So here, my check is just like the horizontal. You're going to check negative 100 and 100. Okay, just so I can finish off this question. Right, so it's just like the horizontal. You're doing the same check, right? When you put it in, I'm going to give you my values. I got approximately negative 94.36. This is the same, I'm going to give you my values, 106.40. So I kept 2 decimal places. I like 2 decimal. But then, what do I compare it to? Remember I said I want to compare to where I'm standing. Where am I comparing it? So last time I was comparing it to y equals 0, right? But where's my dashed line? What do you think?
Like plug negative 100 into the formula for that.
Perfect. That's it. You want to stand on this yellow line, but you got to find out where my yellow line is. So you're going to plug in negative 100 into your plus 6. So into the y equals mx plus b. And you're going to get negative 94. Exactly. So you're going to plug in the 100 to see where the dashed line is. So you go 106. And then my conclusion here is this above or below? So when I'm standing on the yellow line, is it coming from below me or above? If I'm the yellow line, so this is my yellow line, right? My compare is where I'm standing. If I'm standing on negative 94, sorry, and I'm negative 94.36, that is below me, right? And then here, if I'm standing, so the pink is my standing at 106, you're coming from above. And then you write your approach. Okay, so if it just asks approach, you just have to answer the approach part. You don't have to include the word approach. Sorry, whenever I write this, that's just me telling you what I'm answering. You don't have to include that word. So I'll put those in a bubble. But my answer would be the limit as x approaches negative infinity is, wait. And what am I going to write? My line, x plus 6 from below. And then here, x is infinity. And you're going to say x plus 6, my line, but from above my line. Okay, you don't want to give the value. Okay, thank you very much.